In CIST 2611, Chapter 8, we're going to look at how to configure firewalls. So our primary objectives for this chapter is to understand the fundamental firewall functions. We're going to look at common technologies. Also, we're going to dive into the elements of firewall implementation and configuration. So our key concepts of this include firewall rules. So firewall rules, those are the instructions that are going to tell you how the firewall should evaluate and take action on the network traffic. So these are the building blocks for controlling the flow of the data and are very important to effective firewall configurations. We'll also look at firewall policies, the set of rules and the criteria that determine how the firewall handles the traffic. We'll establish a framework for decision making, defining what is allowed and what is not, or what is denied. We'll describe the effectiveness of the firewall limitations and the constraints of those. We'll also look at firewall enhancements, the continuous improvement measures that overcome those limitations with technologies like IDSs and IPSs that are used to enhance the firewall capabilities. The last key concept is the management interface. These interfaces are used for configuring and monitoring firewall settings. It allows you to streamline the administration of those firewall policies because it does provide a more user-friendly control panel for administrators. So first up, we'll look at firewall rules. Now, think of firewall rules kind of like a traffic cop that's directing traffic on highway. So the primary purpose of firewall rules is to filter network traffic based on a predefined criteria that enables us to control which data enters and exits a secured network area. So when we're talking about filtering traffic, so at its core, the firewall rules serve as a gatekeeper. So it filters those data packets as they travel through the network. Now, the filter process is very important because it's set to allow only authorized and safe traffic to pass through while blocking or taking some other type of specific action against any potentially harmful data. So these rules, what they consist of are instructions that evaluate incoming and outgoing traffic based on that predefined criteria. Now, this evaluation process, this involves analyzing various attributes of data packets. These are things such as the source, destination addresses, ports, and protocols used. Now, once that data packet's been evaluated, the firewall rules then dictate the action to be taken. This can include allowing the packet to pass, blocking it, or performing some other predefined action to maintain the network security. Now, there are two main philosophies or security stances we'll talk about: default deny and default allow. So these philosophies, they dictate how the system responds to network traffic, and they're pivotal points in shaping the security posture of an organization. So default deny. This is also known by as deny by default or deny all. So the default deny philosophy operates on the assumption that all traffic is potentially malicious or at the very least unwanted and unauthorized. So in this approach, everything is prohibited by default. Now, some key characteristics of the default deny is that it does have, once again, it's the presumption of malicious intent. So it's saying that all incoming and outgoing traffic, it's assuming can be a security threat. It does have selected permissions. So it only explicitly allowed traffic, which are going to be defined by specific rules, are permitted to travel the network. Now, the default allow, this is also known as allow by default or allow all. The default allow philosophy, this takes a different approach by assuming that most traffic is benign and everything is allowed by default. Now, this one will have selective denial. So in here, only explicitly forbidden traffic, which are defined by specific rules, are blocked. This approach is often more user-friendly. Um, it's less restrictive. But choosing the right philosophy or the right security stance, so that decision between the default deny or the default allow, that depends on the organization's risk tolerance, the security requirements of the organization, and the operational needs. So you want to find a balance between the security and the usability. You find that nice area. Each one of these philosophies are going to have its own strengths and weaknesses. So many organizations may try to adopt a hybrid approach where they implement aspects of both philosophies to create a more effective security strategy. The deny by default, allow by exception, and the default deny by exception, these are often going to be referred to as whitelisting and blacklisting, and they increase or significantly influence how your organization managed to control network traffic. So the deny by default, allow by exception, this approach operates on the premise that all traffic is denied by default. As benign, desired, and authorized traffic is identified, an exception rule is created to grant access to the network. So this strategy is like creating a whitelist, allowing only explicitly approved elements to pass through. This is one that is a more secure approach. On the other hand, the default deny by exception. This approach assumes that all traffic is allowed by default. As malicious, unwanted, or unauthorized traffic is identified, an exception rule is created to block it. This strategy is like creating a blacklist where everything is permitted except for those items on the blacklist, those noted exceptions. Now, with this, the security administrators are on a constant watch for any activity that falls outside the norm. Security policies are going to be configured to allow all traffic initially, with specific rules that will be established to block any identified threats and unauthorized activities. Now, this approach provides more flexibility, but it does require continuous vigilance from security personnel. Now, defining firewall rules is an essential part of a security policy. If your security policy doesn't predefine rules, you want to follow these steps to establish a secure network. First, you want to inventory essential business processes. So you identify and document all essential business processes and communications that will travel the firewall or checkpoint. You want to understand the nature and requirements for each of these communications flow, because you want to ensure that the rules align with the business needs. You want to define the protocols, ports, and IP addresses associated with valid traffic for both the internal and external host. So this clearly outlines the perimeters for legitimate communications. You want to clearly outline those to create a precise and effective rules. You will draft the firewall rules based on the predetermined or the determined perimeters. You want to test the rules in a safe environment. So before you develop these and put them out in a productive environment, you want to test the defined rules where they're in a non-productive environment. That ensures that the rules effectively control traffic while still allowing essential communication. You then will obtain written approval. So you'll submit proposed rule sets to the change approved board or administrators for review and approval. You will document rules in the security policy procedure amendment. So then and you'll submit the amendment to the security policy management team or the administrator for inclusion in the official document. Now, some common types of rules found on most firewalls include access to insecure internet sites, access to secure internet sites, maybe access to internet website protocols like SQL, Java, inbound internet email, and outbound internet email. Now, the purpose of the rule, for example, to access insecure internet website, the purpose of this rule is it regulates access to websites using the unencrypted HTTP protocol. So this is allow or deny based on the source, destination, and possibly content filtering criteria. And what this rule does, this helps control user access to general internet content without encryption. The access to secure internet websites, the HTTP over SSL or TLS. This ensures secure communications with websites that are critical for protecting sensitive information during online transactions. You also have a rule for access to other internet website protocols like Java, SQL, and so forth. This protects against potential security vulnerabilities associated with that specific internet protocol. The inbound internet email rules, this will help filter and control potentially malicious or unwanted inbound email traffic, while the outbound internet email ensures that the outbound emails comply with the security policies and prevent unauthorized data leakage. Now, some key considerations for firewall rules include the source and destination. So you want to clearly define the source and destination address for each rule, the protocol and ports that are going to be associated to allow or deny traffic. Also, you want to consider implementing content filtering criteria that's used to enhance security. For encrypted traffic, the SSL or TLS inspection, this may be applied to ensure that the security standards are met. Now, understanding how network communications function in a two-way transactions is important for creating effective firewall rules. So now most networks communicate in a two-way transaction, exchanges of scenarios, where that information exchange or sessions are established. So you want to recognize the bidirectional nature and how it is important for establishing the rules that enable the seamless and secure connections and communications. You want your rules usually allow inbound responses to initial outbound requests. So you want to allow the return traffic from web page requested by the user's browser. So your firewall rules should permit incoming traffic that is part of a legitimate response to an outbound communication. Now, a single rule can sometimes be defined for both the outbound and inbound communication parameters. So consolidating these rules, these streamline the rule set and simplifies management. And then consider rules that manage inbound communications for externally initiated communications. So if those external entities sometimes may initiate the session or communications with your internal resources, so you want to establish those rules that manage those inbound communications for these. Let's ensure that only authorized and necessary inbound communications are allowed. Now, access control lists are distinct entities from rules and filters, so they're not rules or filters. We can define access control list as they provide a specific mechanism for controlling access to network resources, protocols, and ports. Rules can be defined as written expressions of an item of concern and actions to take when that item of concern appears in the traffic, while filters are the same as rules, are intended to emphasize the intention to block or deny unwanted items of concerns. So access control lists also emphasize the intention to grant or deny traffic on an access control authorization basis. And they focus on controlling the specific users or client access to a protocol or port. So basically what the access control list does is it's a list that's going to determine which users or client can access that protocol or port. And they're often integrated with authentication mechanisms to ensure that access is granted or denied based on that user's identity. Now, when we compose a firewall rule, we first start with we have our base protocol. That's the protocol that's governing the communication, such as a TCP, UDP, or potentially other layer 2 or 3 or 4 protocols. So this specifies the rules for handling traffic based on that protocol. Then we have our source address that specifies the origin of the traffic based on the IP address. Now, this can be set as a specific IP address, a subnet, a range of addresses, or you can type any for all possible addresses. Now, our source port, that specifies the port or the range of ports from which the traffic originates. Once again, this can be set as a specific port, a set of ports, a range of ports, points less or greater than, or any for all possible ports. Continuing into composing firewall rules, we look at the target address. Once again, it sets as a specific IP address, a subnet, a range of addresses, or any for all possible address range. So this is the destination of the traffic. So it determines the destination or the recipient of the traffic to apply the rule. The target port specifies the port or range of ports in which the traffic is directed. Finally, the action. That's going to specify the action to be taken by the firewall when the rule conditions are met. So this is typically include either allow or deny, determine whether traffic is permitted or blocked. Now, some firewalls will include log and alert actions that allow additional actions in a single rule. Now, some of the best practices when you're composing a firewall rule to keep them more effective and easily to manage include keeping the rule set as simple as possible. So these simplified rule sets, there's something that's easier to manage, troubleshoot, and understand. So you want to avoid the complexity. You want to minimize the number of rules to reduce any misconfigurations and improve your overall network performance. You also want to document every rule. So this includes details such as the rule's purpose, conditions, and expected behavior. So these well-documented rules, these facilitate understanding, especially when multiple administrators are involved or reviewing the configurations. You also want to use a change control mechanism to track any type of rule modifications. So this ensures that any modifications are documented, authorized, and aligned with the security policies. And it provides traceability for auditing and troubleshooting purposes. You also want to always confirm default deny before using changed updated rule sets. So this ensures that any traffic not explicitly allowed is blocked, providing that additional layer of security. So by doing this step, this helps mitigate the risk of inadvertently allowing unauthorized access. Now, when you're talking about ordering your firewall rules, the order that they are put, the direction matters. So you want to validate both the source and target addresses. So you'll confirm the correct placement of rules, both in inbound and outbound directions. And this helps prevent unintended consequences and security risks. Now, when you have the wrong rule positioned first, it creates a potential loophole. So, loophole is a flaw in the logic of filtering that allows unwanted actions to occur. So, to reduce this risk, you want to make sure that you have your went through a thoughtful rule ordering when you're placing the rules in your firewall. You also want to place critical deny exceptions early in your rule set. This ensures that they're enforced before the less restrictive rules. You want to prioritize rules for common traffic being closer to the top of the list. This helps improve the overall performance. You want the universal deny rule as the final and last rule. Now, this universal deny rule blocks all traffic that's not explicitly allowed, and that provides a final layer of security and helps to ensure that any unmatched traffic is denied. Also, you want to use fewer rules rather than more rules. So this streamlined rule set, once again, is easier to manage. It reduces the risk of misconfiguration and simplifying troubleshooting. Now, some key aspects you want to take into consideration for your role ordering include that you want to do periodic reviews. So you want to regularly review and reassess the order of your firewall rules. And this is to accommodate changes in the network requirements. Also, you want to collaborate with your stakeholders. And these are people such as your network administrators, security teams, and so forth. You do this to ensure that a comprehensive understanding of traffic patterns and security policies are in effect. Now, understanding what to allow and what to block is critical for maintaining a secure network. So we'll look at some of the steps involved in making decisions for creating these effective firewall rules. First, you want to complete a thorough inventory of your network communications. This includes all protocols and ports in use, well as their source and destination address. And this provides a foundation for understanding the current state of network communications. You also want to determine which communications are mission critical, important, optional, for personal recreation use, or actually malicious. So you prioritize these communications based on the importance to the organization's operation. Then block any traffic you deem malicious or unwanted. And you can do this through an explicit deny or via the catch-all default deny. So you want that information kept from entering your network. Now, some commonly blocked communications include all Internet Control Message Protocol traffic originating from the Internet. This helps prevent certain types of attacks, such as ICMP flood attacks, that can be used for a denial of service attack. Traffic directed specifically to the firewall. So by blocking that traffic directly, that's directed specifically to the firewall, this adds an extra layer of security protection against targeted attacks. So it prevents those attackers from directly probing or targeting the firewall, making it more resilient to any potential exploits. You also want to commonly block traffic, any traffic to known closed ports. So this ensures that even if a service is not actively listing on a specific port, incoming traffic for that port is still denied. This minimizes the risk of unauthorized access attempts to non-existent services or the closed ports. You also want to block any traffic ports of known malware used by back office. So by blocking these traffics to the ports associated with the known malware, such as Black Orphan, this protects against attempts to exploit vulnerabilities or compromise that network. So it prevents potential infections and unauthorized access. Also, inbound transmission protocol control protocol TCP 53 to block external domain name systems transfer zone requests. So this helps protect against potential DNS information disclosure and unauthorized access to the DNS zone data. Inbound user data protocol, UDP 53, to block external DNS user queries. This is just to add an extra layer of protection to that DNS infrastructure. Also, any traffic from an IP address on a blacklist. Traffic from unassigned internal IP addresses. So you also want to think about regularly updating your blacklist with the latest threat intelligence. This helps for more effective blocking. And also consider logging block traffic. By logging the block traffic, this is used for analysis and for potential threat detections. Some essential elements for a firewall policy include a written firewall policy. And this should include several benefits and several purposes that it serves. For example, a guide for installation. So it provides instructions and standards for deploying that firewalls. And this helps to ensure a consistent and secure configuration across your network. You also want to have a guide for the configuration that clearly outlines the rules and filtering criteria that's going to be applied to control the inbound and outbound traffic. This includes you want to specify security measures such as the IDS and prevention settings. And this is used to enhance your firewall's defensive capabilities. You also want to have tools to assist in troubleshooting. This offers a reference point for administrators to identify expected configuration and rules during investigations of network problems. You also want a guide to detect changes and differences. This is support change management processes. And what it does, it clearly defines what changes are permissible and that any alterations are documented and approved. Then you also want a mechanism to ensure consistent filtering across all the firewalls. So you want to promote a uniform security posture. So you define these standardized rules and configurations, and that is what should be implemented across all of your firewall devices. So this part of the policy here, what it does, it really ensures that the firewall policy aligns to the overall organization security policies and objectives. A couple things that the firewall policy should also address is what to log. So you want to clearly define the types of events, activities, and traffic that should be logged by that firewall. You also want the logging location and redundancies. So you want to specify where the firewall logs should be stored. That ensures that the accessibility for analysis and audit. You also want those redundancies built in, such as storing the log in multiple locations or utilizing a centralized logging system. As we say, you want to make sure that you have where to store the log files. So you provide guidelines on where and how long log files should be stored. How often to review the log files. Any add-on enhancements to use. So you specify any recommended add-ons or enhancements that's used to enhance your firewall's capabilities. You also want the firewall administrators who is responsible for it. You want that clearly outlined in your firewall policy. Also, access to the firewall configuration interface, how to access this. You clearly define how the administrators should access the firewall configuration interface. You also want the physical and logical firewall locations. What level of physical access controls are necessary. You may want to consider physical security measures such as secure data centers or restricted area uh, backup and redundancy measures. Once again, so you want to detail how that firewall configuration should be backed up and the frequency of the backup procedures, and also once again address any redundancy issues that need to happen to ensure that the firewall is continuously available. You also want to know how to have your policy address how to manage encryption and where or to use it or disallow it. And then the IDS, IPS, how you will deploy and configure those to interact with your firewalls. There are some limitations in firewalls, and it is important to understand these. So we're going to look at some common challenges and vulnerabilities that are associated with the firewall technologies. First, we programming errors in the firewall software that may be contained. So these errors could potentially lead to unintentional vulnerabilities or some kind of exploitable weakness in the firewall's behavior. A way to help mitigate these is have regular software updates, make sure your patches are installed, and also have thorough testing. And this helps address and rectify these programming errors. Attackers may also attempt to exploit coding bugs or vulnerabilities that are present in the firewall software. And that could result in unauthorized access, bypassing the security controls, or other malicious activities. So you want to make sure you have ongoing security assessments, code reviews, and proactive vulnerability management to mitigate this risk. Your firewalls may also be susceptible to buffer overflow attacks. That's where an attacker attempts to overflow a program's memory buffer. This can lead to a arbitrary code execution or unauthorized access if it is successful. So you want to employ secure coding practices and implement input validation, and this can help mitigate those risks of the buffer overflow vulnerabilities. Now, the fragmentation or fragmentation attacks. This can pose a challenge to firewalls in reassembling and inspecting fragmented data. So the attackers may exploit fragmentation vulnerabilities to evade detection and execute attacks. So you want to make sure your firewall is configured. The configuration includes rules to handle and inspect fragmented packets appropriately as they are needed. Overlapping internal control planting. So your overlapping internal code planting. What this refers to is the insertion of malicious code within internal components of the firewall. So this technique can be used to compromise the firewall's functionality or bypass security measures. So the security controls for this is to implement strict access controls and periodic security audits. And this helps detect and prevent those internal code planting. The denial of service, the DOS flooding. So your firewalls may be vulnerable to the DOS attacks, where the attacker overwhelms the firewall with excessive traffic. This can disrupt the normal firewall operations, and it can also lead to denial of service, the service outage. So you want to employ rate limiting, traffic filtering, and intrusion prevention measures. And this will help mitigate the impact of a DOS attack. So some things that you want to keep in mind when to help to limit the firewall limitations. You want to have regular updates. You want to keep your firewall software up to date with the latest security patches and updates. You want to conduct regular security audits. This includes a vulnerability assessment and penetration testing. And this is to identify and address any potential weakness. You want to emphasize secure coding practices during the deployment of the firewall software. And that's to reduce the likelihood of the vulnerabilities, the development of the firewall software. And that's to reduce the likelihood of those vulnerabilities. And they also want to put in place a comprehensive network monitoring to detect and respond to suspicious activities and potential attacks. Now, improving the performance of your firewall, this is something that's very important for maintaining a responsive and effective network infrastructure. So, we'll look at some key considerations and strategies to enhance your firewall's performance. Now, we're going to particularly focus on the network communication speed and high availability. So, your network connection speed is a common concern. So, you want a properly installed firewall. That properly installed firewall that should operate at wire speed, meaning it does not introduce any significant delay or latency in the communication. Now, you achieve wire speed. This is something that's going to be important for ensuring that the firewall does not become a bottleneck in the network. That allows the data to flow at a maximum possible rate. Now, some criteria for improving the firewall is caching and load balancing. So you implement caching mechanisms to significantly enhance that firewall's performance. So this involves storing frequently accessed data or responses, reducing the need to repeatedly process identical requests. Now, load balancing distributes network traffic across multiple servers or resources, ensuring that a more distributed distribution of the workload. So this prevents any single firewall device from becoming overloaded. Now, high availability is often associated with the load balancing and network availability, and it's measured as a percentage of time when the service or device is available to users on the network. Now, we've talked about caching in the last slide. Caching involves holding often accessed content and storage or memory on the firewall. So instead of fetching the content from the original source every time, the firewall receives it from its cache. And this improves the performance by borrowing from proxy servers. And it's quicker access. So it transforms that firewall into a proxy server of sorts. Now, load balancing distributes the firewall filtering workload across multiple parallel firewalls. Now, the primary goal of this is to ensure that the workload is distributed efficiently, allowing for deeper packet inspection while maintaining the wire speed. This also provides redundancy and fault tolerance. So if one firewall fails, others can seamlessly take over to ensure the continuous service. Now, there are benefits that we need to recognize and challenges that are associated with the use of encryption in our network security and with firewalls. So the benefits of properly used firewalls is they protect the data in storage and transit. They provide confidentiality protection, and they prevent unauthorized third parties from gaining access to the secured content. Now, the downside of encryption with firewalls, the firewall is not the intended destination for the encrypted communications. So encryption is designed to secure communications between endpoints. The firewall is typically not part of the encryption decryption process. The encryption data cannot be filtered by a firewall. So this limitation arises because the firewall inspects the traffic at the application layer, and encrypted data is unreadable at this stage. It's also not useful to protect against malicious traffic when filtering tunnel mode encryption. So when the encryption operates in tunnel mode, the firewall is unable to inspect that encapsulated data, so it limits its ability to protect against malicious traffic within that encrypted tunnel. It also has difficulties performing network address translations. So it usually faces those challenges of performing the NAT for the encrypted traffic. So NAT, once again, is a technique used to map private IP addresses to public IP addresses. So it's not as straightforward with encrypted data. Now, some mitigation strategies to consider for this. Some firewalls offer the SSL TLS inspection capabilities, which allows them to decrypt and inspect the encrypted traffic. Now, this does introduce complexities and privacy concerns. You also can focus on the application security measures such as IDSs and prevention systems. That's to use to identify malicious activities within the encrypted traffic. You also may want to implement proxy servers. So this may provide a workaround for inspecting encrypted traffic. It does introduce, though, additional points of potential vulnerabilities. So some enhancements to traditional firewalls, we will look at some additional features and functions that can contribute to a more comprehensive and adapted security infrastructure. First is malware scanning. So the firewalls enhanced with malware scanning capabilities, they integrate threat intelligence and signature-based detection to identify and mitigate malware. So it provides real-time protection against known and emerging threats, preventing malicious content from entering your network. Some firewalls may have IDS features to identify and alert administrators about potential security incidents, or they may have IPS features where they take proactive measures by actively blocking or mitigating identified threats. Firewalls, VPN endpoints, they facilitate secure remote connectivity by providing a secure tunnel for data transmission over the internet. So it enables the creation of encrypted connections that ensures the confidentiality and integrity of the data transmitted between the remote users and the network. Now, Unified Threat Management, or the UTM, this consolidates various security features into a single solution. It's including the firewall, the antivirus, IDSs, IPSs, VPNs, and content filtering. And it makes it easier for organizations to deploy and manage multiple security features with that unified platform. And then virtualized firewalls operate in the virtual environment. These offer flexibility and scalability and can be easily deployed and scaled based on the changing network requirements. This is something that may be well suited for a cloud environments. Um, some other things with firewalls include the management interface. So we'll look at some key considerations and best practices for managing our firewall interfaces. So now a firewall's management interface may be command line based or it may be a graphical. So you choose the interface type based on administrator preferences and the expertise, but you also want to make sure that it aligns with your security requirements. You want to physically secure the firewall's management interface by restricting physical access to authorized personnel only. And you also want to implement any logical security measures, such as your secure protocols and encryptions, to protect against unauthorized access and data interception. You also want to use strong authentication process. Now, this includes multi-factor authentication to ensure that only the authorized individuals can access the firewall's management interface. So you want to enforce robust password policies, also to ensure the security of authentication credentials. You want to limit the methods used to access the firewall's management interface based on the organizational's principle or organizational's policies. So you want to apply the principle of least privilege to ensure that only the administrators have access and the necessary rights for their roles. You want to ensure the communication pathways for accessing the management interface use secure protocols such as HTTPS or SSH. You may want to consider using a virtual private network, a VPN, for secure remote access to the management interface, especially if you have administrators working outside of the corporate network. You also want to disable access on outward facing ports. So you disable the access to the management interface on every physical network interface on the or port that faces outward. That reduces your attack surface. You want to disable access to the management interface on every physical network interface or port that faces outward. So this, you also, when you're doing this, you want to implement network segmentation. So you want to isolate that management interface from the external networks. You also want to configure the firewall to record all attempted and successful connections to the management interface into a log file. This is to, when you conduct your audit trails, you can find and trace for accountability and post-incident analysis. And you want to verify all the settings remained as configured. And you will conduct audits to ensure the compliance with the security policies as well. So in this chapter, we've talked about firewall rules, or instructions or filters that control the flow of data, entering and leaving a secured network area. So they filter that traffic based on predefined criteria, and it allows the organization to control and secure your network communications. The firewall policies we've talked about as being a set of guidelines and rules that dictate how a firewall should function and what traffic it should permit or deny. So this serves as a framework for configuring firewalls to align with the organization's security objectives and requirements. With firewall limitations, we've talked about the challenges that you will face, including programming errors, susceptibility, coding bugs, vulnerability, buffer overflow attacks, and difficulties in handling encrypted traffic. So we talked about, by recognizing these limitations, it's important for implementing complementary security measures and strategies. We've talked about firewall enhancements in this chapter, and that includes malware scanning, IDS and IPS capabilities, VPNs, endpoints, unified threat management, and virtualized firewalls. So these enhancements augment traditional firewall capabilities, and it provides a more comprehensive defense against the evolving cyber threats. Lastly, we talked about the management interfaces, that they may be command line based or graphical, providing administrators with the tools to configure and monitor your firewall settings. Now, our security practices for the management interface, once again, we talked about both physically and logically using strong authentication, limit access methods, consider your communication pathways to disable outward facing access, and maintain a thorough logging for security monitoring. So the key takeaways for this chapter include that effective firewall management involves defining the rules, policies, and considering both the strengths and limitations of the firewalls. Those firewall enhancements contribute to a more robust security posture by addressing contemporary threats, and our security management interface is important. This involves physical and logical measures, strong authentication methods, and access limitations, and vigilant monitoring.